Good morning, everyone, and welcome to my session. My name is Duncan Epping. I'm a chief technologist working for VMware in the storage and availability business unit. Today I'll be talking primarily about virtual SAN, which is our hyper-converged offering. Hopefully the majority of you guys, and women as well, by the way, have seen this slide before. So this slide is all about the software-defined data center, and hopefully the majority of you know that the software-defined data center is all about abstracting resources and offering them in a pooled fashion, which can also be used through different automation tools. Now, those who are responsible for data centers know that over the last couple of years, the primary pain point in the data center, A, has been the network, but B has also been the storage platform. And today what I'll be talking about is trying to figure out how we can make those pain points in terms of storage disappear. Now, over the last couple of years, we've seen a true revolution going on in the storage industry. The key reason for that being is the hardware components have all changed significantly. And when I talk about hardware components, I'm not just talking about the introduction of Flash or NVMe, but I'm also talking, for instance, about the network, 10 gig networks, 40 gig connections, 50 gig connections, and we're even talking about 100 gig connections. And then we're starting to move into the new space around RDMA connected devices as well. So a lot of these changes has allowed us to start changing the architecture from a storage point of view as well. I'm not just talking about vSAN, but I'm also talking about other types of storage solutions, like, for instance, solutions like Nimble, who are out here today, or Pure Storage. The key reason they were capable of introducing a new storage platform, which is easy to manage, easy to consume, but easy to set up as well, is because of all of the changes from a hardware perspective. No longer do you need to have 5,000 spindles to offer your users 10,000 IOPS, for instance. 10,000 IOPS can easily be provided by a single SSD. So a lot of these changes that we've seen from a hardware perspective have truly led to a storage revolution. Now, what we're trying to get to from a storage perspective is not that just changing the storage industry, but it's actually changing things from an infrastructure perspective. Someone once said that the best admin is a lazy admin. I don't know if there are any administrators in the room, but I'm pretty sure that you guys will agree with me. The key focus for an administrator is typically to do the job in such a fashion that they typically don't have to do anything during the day. So hopefully the majority of tasks that you have, the standard processes and procedures, have all been automated by now. When I look at the infrastructure today, though, this is what it typically looks like. You see a lot of switches. You see a lot of these meters. You know, you need a couple of people to actually drive or fly, in this case, the solution that we have over here, which is an airplane. And this is what the typical data center looks like. You have a lot of these, what they call nerd knobs. Now, the challenge with a lot of these nerd knobs is how do you use them? What do you need to set them to? And that's not the goal that we have from a vSAN perspective. Our goal is primarily to make your data center look like this. Now, the great thing about this device is that it looks really, really simple. Right? It only has one dial. You set the temperature, and you're basically done. That's what you do. Now, the great thing, what's even better about this device, is that it has an API, and you can fully control and manage it. You can write your own tools around it. You can have it do all sorts of smart things through these APIs. And we're trying to achieve the same thing from an infrastructure by providing you something that we call a hyper-converged software stack. Now, if I look at a hyper-converged software stack, and we just saw these different nerd knobs, as we like to call them, what does it look like from an IT perspective? Most of you have probably seen this screen, right? A user comes up to you and says, well, I have this database, and I want to deploy this database, and I need to have some form of storage for this particular database as well. Does it need to be RAID 10? Does it need to be RAID 1 versus RAID 5? Where do I want to store this virtual machine? Can the storage that is being put on, can it be, does it need to be replicated? Can it be thin provisioned? Can it be deduplicated? Is it compressed, for instance? All of those different factors will, in some shape or form, basically change the behavior of the VM and the experience for the user as well, either from a performance perspective, but potentially also from an availability perspective. Now, if you look at this screen, and this is literally one of the spreadsheets that one of my customers use to manage their virtual machines and their storage environments, it becomes fairly complex. You know, in this case, this guy has 17 clusters, many different storage devices, and in order for him to pick the right storage device, he ends up going to the spreadsheet, figuring out, you know, where he needs to place the VM based on the different capabilities that the storage devices have to offer, so whether they are replicated or not, if there's any capacity available, and then he selects a compute cluster. You can imagine that this process, A, is very tedious, but B is also relatively error prone. Right? If he picks a data store which is not replicated while the data needs to be replicated, he can find himself into a situation where he doesn't want to find himself into when something happens to the virtual machine or the data center even. Now, from a VMware perspective, we do have a great solution around this, and the key reason we've been able to build a great solution around this is because of the fact that we own the hypervisor. Hopefully, most of you know what VMware vSphere is and what it does, but it allows you to run many virtual machines on top of a single physical host. That's the key essence of what we do with vSphere. We virtualize workloads. Now, if you look at this picture, every single virtual machine that runs on top of it, and whether that's Exchange, whether that's SAP, Oracle, or just a generic Windows workload, every single workload will need to go through the hypervisor to access some form of storage. And whether that storage is just regular SAN or NAS storage, or is local storage and being exposed through vSAN is even besides the point. But in order for the virtual machine to store something, it needs to go through the hypervisor. And as soon as it needs to go through the hypervisor, we can start doing smart things with that particular I/O or those particular blocks. Now, when it comes to these different virtual machines at the top, and we just saw the spreadsheet, the key thing here is not about what we can do with the I/O itself, but how we do that. If you look at this screen, if there's anything you need to take away from this section, it's this particular screen, storage policy-based management. Storage policy-based management is all about avoiding using that particular spreadsheet that dictates where a virtual machine should be stored. Storage policy-based management allows you to create policies and define within that policy what the requirements are for your application. So if you have an Exchange database and you want to have some form of caching, you can define that in a policy. If, for instance, you have an SAP solution, you want to replicate that to a second site or to a third site even, or you want to back that up in a particular way, you can define that in a policy as well. As soon as you define these policies, you can now attach these policies to virtual machines, and magic, literally magic, will happen on the back end. So what does that mean? As soon as you define a policy, the storage platform itself will figure out what needs to happen to that virtual machine based on what you've specified in the policy. This also means that if over time, for whatever reason, the requirements of your application change, you don't move that particular virtual machine or those virtual disks to a different LUN or to a different storage platform, potentially a different cluster. No, you simply change the policy itself and you apply the policy to the virtual machine. When that policy gets applied to the virtual machine, the storage system itself will figure out what to do with those particular disks. So whether it needs to move on the back end to a replicated environment, or whether, for instance, something needs to happen to that object itself. So storage policy-based management is key when it comes to hyper-converged platforms. Now, vSAN, of course, heavily leans on the storage policy-based management platform, and I think it's one of the most important things of our offering itself, and it's one of the ways we differentiate ourselves as well in the industry, if you compare us to some of the other hyper-converged solutions out there. But what is virtual SAN itself? Well, I've already mentioned it a couple of times, but virtual SAN is a hyper-converged infrastructure-based solution. So what does that mean? Well, basically what we did is we created a software-based solution, which is part of vSphere. It's part of the vSphere cluster level object. So if you go to the vSphere cluster level and you've enabled HA and DRS, there's another tick box there that allows you to enable vSAN. It's that simple. And then what we allow you to do is we allow you to leverage all of the local resources in a host itself. So what does that look like? Well, if you look at the diagram here, you'll see at the bottom a bunch of boxes. Those boxes can be any type of service. Could be Dell, HP, or just generic white boxes, depending on what your preference is. Those boxes will typically have some form of storage. And these are generic x86 boxes. There's nothing special to it. In this case, though, we'll see that they have SSDs, but they could also be a combination of SSDs and regular spindles, for instance. So we leverage these local resources, we take these local resources and we serve those up as one single shared data store in your environment itself. So you'll only see one single data store. You no longer need to think about where to deploy your virtual machine because you only have a single data store. As I just said, all of the different characteristics can actually be defined in the policy itself. So availability, performance is defined in the policy. The virtual machine itself will go on top of that single vSAN data store. Now, the great thing about this, of course, is that it fully integrates with some of the other solutions that we have in our offering. If you look at things like vRealize Operations, vRealize Log Insight, there are management packs for virtual SAN itself, for vRealize Operations and vRealize Log Insight, but it also integrates with things like View. So if you're a desktop user, you use our View products, you can leverage vSAN as a storage platform as well for View. And it's actually bundled into the View's Horizon suite. So if you're a Horizon customer, you have the Horizon suite, Advanced or Enterprise, you're actually entitled to vSAN. So you can use that as your storage platform instead of using the traditional storage array you may be using today. Now, from a vSAN perspective, the question that typically comes, okay, what kind of services do you guys offer? What kind of features do you guys have? And there's a lot of features on this list, and I'm not going to go over them one by one because I only have 30 minutes, unfortunately. But I think there's a couple of key ones, and I'm going to address them in the next couple of slides. The one thing I find interesting when it comes to this slide is the release cadence of virtual SAN itself. The first release was in 2014, which coincided with the vSphere 5.5 release. So it's called vSAN 5.5, but actually was the first release of vSAN itself. A year later, we actually released the second release where we doubled the performance, which was probably one of the key things that we did. Plus, we introduced a very performant snapshot technology as well. Now, the interesting thing here is that 6 months later, we introduced version 6.1, which introduced things like stretch clustering, but for instance, also a new health monitoring tool. And another 6 months later, we introduced vSAN 6.2, which was 2 months ago, which released functionality like deduplication and compression. So we've changed our release cadence to a 6 months basis instead of the traditional vSphere-based 1.5, 1 year. The key reason we did that is to ensure that if you, the user, or the administrator, or the consultant has particular features he likes to see in our product, we can actually act on those relatively quick. So in some cases, for instance, we've been capable of introducing new functionality within 4 months based on customer requests. Now, if you look at vSAN today, and I think some of our competitors will disagree with this, but the numbers will prove me correct, is that vSAN is the most widely adopted hyper-converged platform out there. As it stands today, we have over 3,500 customers, and last quarter we did about 20,000 units that were sold, so CPU units, which is quite substantial in the hyper-converged industry. Now, in this example, we have customers ranging from financial institutions. There's actually a large financial institution that just bought into vSAN based out of London. I can't mention the name, but it's a really big one. But we have customers ranging from financial institutions to really small shops, so ranging from 2 to 3 nodes, but also interesting use cases, like, for instance, this example, which is an oil platform. So in this example, we have a customer actually installing and configuring and using vSAN on an oil platform. The key reason for them to do this is basically the operational simplicity. They don't have anyone on those types of ships that actually understand infrastructure. They don't have anyone that understands storage. Someone may understand how the application works, but that's about it. So they need to have something that's really easy to set up, that's easy to manage, and that's the key reason they ended up buying into vSAN. Now, there are some other interesting use cases as well. So there are some military or government agencies that are actually using vSAN for typical deployment. So this is the deployment that they used to have, which is traditional storage and a traditional rack-based solution. You can see it's a significant amount of capacity that they need to drop into those different sites. So in this case, what they end up doing is they take this particular unit, they ship it through a helicopter, and actually drop it into the different locations where they need to have some form of compute available. So when they heard about vSAN, they felt it was an interesting solution. So what these guys ended up doing is they ended up building their own solution for these particular deployments. So what they did is they built a new solution which basically allows them to have, instead of have that half rack full of equipment with storage and compute, have everything self-contained within literally a couple of units. So they literally went from that first box that you saw to this crate. You can imagine that that makes a big difference in terms of A, the cost of shipping it, B, the cost of power and cooling, you name it, if there even is some form of cooling. And what they also noticed that these, the vSAN solution, because it's all flash, also led to a lot less failures because of the the fact that typically in these scenarios there is no cooling or whatsoever. So needless to say, but these guys are very happy about virtual SAN. Now, if we look at the different use cases, I've just mentioned some of the enterprise customers that are using virtual SAN. We have customers using virtual SAN for all different types of use cases. We see a lot of customers using it for business-critical applications, whether that's Oracle, Exchange, SAP, or any of the other solutions that are out there. We also see a lot of customers doing end-user computing. But the easiest use case, or the typical use case that a lot of customers actually end up using it for first, is the management use case. Now, the key reason they use it as a management cluster is primarily because what we see in a lot of data centers where they have a lot of hosts, they have 100 hosts, 200 hosts, maybe 500 or 1,000 hosts, is they end up running their management software on top of the environment that they're managing. So their management virtual machines run on top of the same storage system as they are managing, which means you have a circular dependency. With vSAN, as you create a standalone storage environment, you create a standalone cluster. If anything happens to your production environment, your management workload will always be available. So that's one of the key reasons we see customers moving towards virtual SAN. The other one that's interesting is DMZ, the DMZ use case. A lot of my customers are running a significant amount of web-facing workloads, and unfortunately recently a couple of them were hit during a denial of service attack, which didn't only take out their web front end, but also took out their back end. The key reason for that was because of all of those web front end servers running on the same storage system. So you can imagine that if you, for those particular environments, set up a dedicated cluster with vSAN, that if anything happens to your DMZ, nothing can or will happen to your production workloads. And that could be running on vSAN as well, but it could also be running, for instance, on a traditional storage system. Now, the question that typically comes in, okay, that sounds great, but how do I go about deploying these types of solutions? Well, there are a couple of ways you can go about deploying these solutions. The easiest way definitely is VxRail. VxRail is being sold through EMC, VCE, I should actually say. And it's that hyper-converged offering, which basically means that virtual SAN, vSphere, and Log Insight comes packaged as a single solution, and they will provide you support on top of that as well. So it's sold as a single SKU solution that includes support, all of the hardware components and all of the software components, if you want to include those. If you're one of those customers that already has an enterprise license agreement or already has vSphere licenses or vSAN licenses, you can also buy this solution without actually including the licenses or the support. The choice is up to you. Now, if you want to have some more flexibility and you actually want to pick a specific server range from a specific vendor, you can actually go do that using the vSAN Ready Node solution. The vSAN Ready Node solution is basically an offering from every single server vendor in the world that allows you to set up and run vSAN in a fully certified and very efficient way as well. So what they did is they picked a couple of their servers with certified components, and they offer them through their website as a single solution. Some of these solutions will also come with ESXi and vSAN pre-configured for you, by the way. So it's very easy to set up and literally takes a couple of clicks. Now, when it comes to these offerings, there are two different types of flavors. First of all, the hybrid flavor, and then secondly, the Allflash. The hybrid flavor is the flavor that has been used the most up till now. Key reason for it being is that flash has been relatively expensive over the last couple of years, but the world is slowly changing. So what we've been seeing over the last couple of months is that a lot of our customers are now starting to look at all-flash environments. The key reason for it being is that the cost per gigabytes in terms of all-flash has come down dramatically. And on top of that, what we've already also started seeing is that a lot of these flash devices are starting to increase in terms of capacity as well. So, for instance, it's relatively affordable today to have, for instance, a 4 terabyte flash device, but we're already starting to see 10 terabyte and 16 terabyte flash devices on top of that. So you can imagine that with those types of devices, with low dollar per gig prices or euro per gig prices, or even pound per gig prices, I should say for you guys, is that it started to change the economics around hybrid versus all-flash. Now, the great thing about hybrid and all-flash is that they will perform relatively well in both ways. The hybrid solution will do roughly 40,000 IOPS, and you will see that the all-flash solution does 100,000 IOPS. Now, that sounds great if you're a geek like me, but what's more important is the latency, right? From a hybrid perspective, you still have the latency from a disk point of view. So if a read or a write needs to go to disk or comes from disk, then you will also have the latency that comes with that. From a flash perspective, of course, you won't have that experience, which also means that you will see sub-millisecond latency when you start moving towards all flash configurations. Now, I've mentioned it a couple of times, and I said that vSAN is really simple to set up. But this is literally the screen that allows you to set up vSAN. And if you pay close attention, there's a section at the top that says disclaiming. You can enable or you can disable compression and deduplication. Maybe you want to create a stretched cluster environment. You have multiple locations within a single site or across sites as well, for instance, multiple data centers, you name it. You can do all of that in the UI. It literally takes a couple of clicks. The first release that we had literally takes two clicks. Now it takes about 4 or 5, depending on the data services you want to enable. So relatively easy to set up. I don't know if anyone is a storage administrator in the room, but I'm pretty sure that most of the storage systems will not allow you to do the same thing. Set up a storage system literally within seconds. After you've defined, or when you create that vSAN data store, the next thing you'll need to do is define a policy. Now, the policy definition is fairly straightforward. You define what kind of availability capabilities you want to specify, or you would like your VMs to have. For instance, if you want to set an IOPS limit, and if you need to have a read cache reservation. And after that, you assign that policy to a virtual machine. Relatively straightforward, easy to use. If you understand the vSphere interface, you will understand the policy-based management framework as well. Now, there are a couple of new features that we introduced in 6.2. I'm going to glance over them fairly quickly because I'm pretty sure that most of you understand what deduplication is, but I think it's important to understand that we actually offer it as part of our platform. 6.2 introduced deduplication and compression. You can enable it on the cluster level. Again, it's a single click. It literally takes 2 seconds to enable, and what allows you to do is compress and dedupe every single block that comes in. So we do this on the 4K granular level, which means that it's relatively effective as well. And what you will notice is that typically you will see a 3x or a 4x data reduction, all the way up to 7 or 8x, depending on the type of workloads that you're running. I'm not going to give you a guarantee here, because that would be some form of false advertisements, but these are the typical numbers that we typically end up seeing in most environments. Now, besides doing the compression and deduplication, there are other ways of ensuring that the capacity is used in an efficient way as well. So one of those other ways, for instance, are storing your blocks in an efficient manner. You can do that through a couple of ways. Most of you are aware of what RAID 1 is, which basically means you have 2 full copies of the data. What you can do from a storage perspective as well is, for instance, do RAID 5. So we introduced RAID 5 as a network-based solution, which is what we refer to as inline erasure coding, or RAID 5 or RAID 6 over a network. And basically what this allows you to do is, through policy, define how many copies of your data you would like to have, and then store them in a relatively efficient manner as well on top of the vSAN data store. So in this example, normally with RAID 1, you would have 2 full copies of your data. So if you store 100 gig of data, you end up with 200 gigs on the back end. With RAID 5, that 100 gig of data is actually stored as 133 gig on the back end. So the overhead is only 33% instead of the 100% overhead you would normally have. So a lot of customers are really interested in this for that particular reason. Now, of course, when it comes to availability, I think this is probably one of the most important aspects. We do a lot of smart things. First of all, we always ensure that we have multiple copies of the data. So in this example, you see multiple copies of the data, which is the VMDK, which is represented in this diagram. But depending on what your architecture looks like, or what your data center should look like, I should actually say, you can imagine that you have multiple racks. And if you have multiple racks, you may want to distribute the data across multiple racks as well, if you consider that single data set, that single rack to be a failure domain. So you can do that with Virtual SAN. You specify what your data center looks like, and we will actually move the data around to where it should be located based on the availability constraints and requirements that you've provided. Now, on top of that, if you have multiple sites, you can also specify that in the UI, and through policy also specify where virtual machines or data should be located. So in this case, because we have multiple sites, we want to make sure that the data is available across multiple sites, and through policy we actually specify that the data, that one part of the data needs to be in site A and the other part of the data should be in site B, and then there's this witness thing as well that we use as a quorum mechanism. So this allows you to actually have that redundancy across sites. Now, if for whatever reason you need to have a third site on top of that and replicate your data out of that and leverage something like Site Recovery Manager to do orchestration in case both of the other sites have failed, we also allow you to do that with Virtual SAN. Now, having said all of that, and it sounds cool from a technology perspective, things like RAID 5, RAID 6, deduplication, you name it, when it comes to it, the majority of time you guys spend typically is in the vSphere interface. So a lot of the day-to-day tasks are in the vSphere interface. You try to figure out how a virtual machine is behaving, how is my cluster behaving, and you can do all of that from a vSAN perspective also through the same interface. So all your day 2 operations will happen in the same interface. For vSAN, this basically means that we created something that we call a health check plugin, and this health check plugin will show you what the state is of your particular data store or your particular environment. So it will show you if there are any issues with disks, if there are any issues with flash devices, if any particular virtual machines are not adhering to the policies that you've defined. But for instance, we also have different tests that you can run, and if there's an issue, we'll actually show that in the interface itself. So if you have multiple sites, for instance, and you're exceeding the latency thresholds that we've defined, we'll also specify that within the UI. Now, on top of that, of course, we can also provide you very deep down informative information around the performance of a virtual machine. So if you want to know how a virtual machine is performing, how a virtual disk is performing, how a physical disk is performing, or even how an SSD is doing, you can see all of that information in the vSphere UI itself. On top of that, if you have something like VROps, you can use the management packs to actually pull all that information into VROps and look at it at your environment across the board. So if you have multiple clusters, you can have all of that information being rolled up into VROps on top of that. And of course, from a capacity perspective, we also provide you all of the details that you would ever want to see from a vSAN perspective. And whether that's around something like swap files, or for instance, the cost of a replica when you're doing a RAID 5 versus doing a RAID 1, all of that information is being shown in the interface. Now, one of the things that I haven't spoken about, and which is also shown in the interface here, is the swap files. And I just mentioned that 6 months release cycle, and I think that's an interesting one. 4 or 5 months ago, one of my customers came up to me and said, you know, I've been deploying virtual machines on top of vSAN, but the problem I have with this is the cost of the swap file itself. So hopefully all of you guys know what a swap file is. But a swap file is basically a file that allows us to swap memory pages to disk when there's memory contention on a hypervisor level. Now, that swap file is something that we need to reserve on the vSAN data store. And the customer said, well, there's a cost associated with it because I'm not doing any overcommitment from a memory perspective, but you guys are still creating that swap file. So I had a discussion with him. I went back to the engineering team and I said, you know what would be cool? If we could create thin swap files. So the swap files will come at no cost. So the engineers looked at the code and they were capable of introducing that feature literally in the next release, which was in the 6.2 release. And that's the power of doing a 6 months release cycle. Now, before I'm about to wrap up, there's a couple of things I want to leave you guys with. I've already mentioned virtual machines, probably 1,000 times by now. And the common conception is that virtual SAN is a storage platform that was designed for virtual machines, but that's truly not the case. Virtual SAN is actually designed as a generic object-based storage platform. The performance stats that I've just shown you, those performance stats are actually stored as a database on top of the vSAN data store itself. They don't sit within a virtual machine, they're not pulled into vCenter itself, but they're actually part of the vSAN data store as an object. Right? And you can imagine that we could do the same thing with other types of data as well. And whether that's Docker containers, whether that's virtual machines being deployed through OpenStack, or whether you're using, for instance, Pivotal Cloud Foundry to deploy replications. All of those different types of applications and solutions should be capable of leveraging the vSAN data store. That also means that from a vSAN perspective, we're aiming to change some of the ways you can access the vSAN data store on top of that. Right? So today you access it primarily as a VMware type of data store, which is something that's exposed through vSphere itself. But you can imagine that in the future you can do the same thing and leverage it as a block device, which basically means connecting to it over iSCSI, for instance. Or potentially use it as a file service as well, so using something like NFS or CIFS. Or maybe you want to connect to it over S3 and store your backup data over there as well. All of those different things should be possible. Now, when I started, I mentioned that hardware evolution actually started the revolution from a storage perspective, but I think if you look at it, what we're actually doing is changing the industry from an infrastructure perspective once again. We've already introduced technology like HA, DRS, vSphere itself, ESXi, you name it, all of those cool features that you guys are probably using. And I think vSAN is doing the same thing once again when it comes to the infrastructure. And with that, I've reached the end of my session. Hopefully it was useful to you guys. I will be walking around quite a bit here, so if you guys have any questions, let me know. And thanks for attending it, and hope you enjoy the rest of the show. Thanks.